Hello. Yeah. Can you hear me? Am I audible?
Yes, sir.
Okay, very good.
Yes, sir.
Now, good morning. Let's about yesterday's class. Any queries that from anybody? Are you able to see the screen? Yes. Nobody is replying. Are you able to see
Sir.
this? Okay, good.
Yes, sir.
Now, before we get into today's class, let's see about few questions related to yesterday's discussion. So, please, one of you can answer this one. Which topology requires a central controller or a hub? There are four options given here. You can see and tell the answer.
Bus.
Read the question. Which topology requires a central controller or a hub? Yesterday we discussed this one under topologies. Anybody else? There are 30 people now in the class. Nobody is responding. You can unmute your mic and reply. Which topology requires a central controller or a hub? It's a star topology, right? Bus is just like a multi-point connection. All stations can be connected to the same wire. Whereas star, there is a central point which every station is connected directly to that. Now you can see that which topology requires a multi-point connection. This is a bus actually. Okay. Now let me ask one more question here. A television broadcast is an example of what type of transmission it is? Simplex, half duplex, full duplex, or automatic? What type of it is? Television broadcast. Just recollect what is simplex, what is half duplex, what is full duplex. Then you will know what is the correct answer.
Simplex.
Yeah, good. Because it is always one transmitter and receiver can be one or more. Then just one more before we go to the today's class. In a dash connection, more than two devices can share a single link. More than two devices can share a single link. What is this one? Point to point, multi-point, primary or secondary? Anybody?
Multi-point.
Okay, good. It's a multi-point, right? Okay. Then this is already posted in LMS, and the answers also is there in this. I mean, at the end of it, you can just go through it, right? Okay. And we go to today's class. Now the new screen is visible to you, right?
Yes, sir.
Just one to event again to the same thing, not this. Yeah. Now today we're going to discuss different network models or network communication models. It's strictly speaking, it is a communication model. There are several models of communication proposed by several organizations or agencies, but out of that, two of them are very popular and they are commonly in use by several people in the industry. Those two we are going to discuss now in this class, and out of that, one of them is going to be the final model, which is related to our subject. Okay, so that model we'll discuss in more detail throughout the subject. But before that, let's see what are those two popular models. So this communication is always established in a form of layers. We'll see what is this layers. Okay. We use concept of layers in our daily life as an example. Let's see what is these layers. Let us consider two friends who wants to communicate through postal mail. Okay. The process of sending a letter to a friend would be complex if there are no service available from the post office. Say, those two friends want to communicate each other who are located at different places, not at the same place. The same place means they can directly meet and hand over to them. They are in a different cities. So the only possibility is one of them has to go to other place and hand over it or collect it. But that is maybe to some extent simple if only two are involved in the communication. Imagine there are n number of people are there, where n is 10 or 20 or 100,000, something like that. And each one should be able to send these mails or letters to different people. Right? Each of them wants to send to different people, maybe more than one or two, something like that. Then you see how complex it is. Can everybody go and deliver or collect from other places? Is it very, very impossible? So that's why we need a setup, and now existing setup is post office. So how the post office works, let's see. To deliver these letters or ensure that the communication from anybody to anybody properly takes place. Let's say there are sender and receiver, two people are here. Sender, what is his letter, whatever he wants to write the message, he writes on the paper and put in an envelope and close it, seal it. And then after that, we'll put in a mailbox, right? Mailbox, this one, or post box. Okay, the letter is collected from the post box by a postman. Okay, and he takes it to the post office. So at post office, what happens? So different postmen collect these letters from different post boxes and bring to the post office. At post office, they sort out city-wise or destination-wise how they, in which direction they have to travel. I mean, go. Then after that, those letters will be handed over to the parcel courier person going in that direction, or who is providing service in the direction of that city. That courier person will carry it to the destination city, and there he delivers to the post office in that city. That post office here again further sort out this area wise and hand over to the postman who is servicing that area. That postman carries it to the address of the person in his area and hand over to that. Then that person recipient opens the letter, envelope, and gets the contents of that, message. So that's how it happens, right? Here you see how many people are there. Because of this, the sender is always, he is not moving out, he is there. And similarly, receiver is not moving anywhere, he is also remaining in his place. But they are able to send or receive it. And imagine this can happen for any number of people because of this postal setup available there. Same type of communication system is required for data communication also, because there are several senders, several receivers. Anybody can communicate to anybody. So we need a big setup. That is what this model what we are talking about, and we are going to discuss about. These are called layers because here what is that here? Sender is involved here. Then postman, post boxes, postman to post office, and then courier person. So many people are involved. Courier person does his own work, only carrying and delivering at the different cities. Post office, his job is only sorting out, and similarly at the destination post office, again sorting out and over to the postman. And the postman at the sending side, collecting from post boxes and handing over to post office. At the receiving gate, collecting from post office, handing over to the person. And here, sender preparing a letter and putting in an envelope and sealing it and dropping in the postbox. Whereas the receiver, once he receives, open the envelope, reads and get the message. So everybody doing his only his part of the job, but nobody is doing other part of entire work, right? So these are called layers, which means when you are functionally dividing the whole task of sending a message from sender to receiver into multiple tasks, each task is handled by a different person, or each task is handled by a different layer in computer network. So that is the one we are going to do it. So this is useful because here, because everybody is doing his own work, so he can be more efficient. That's number one, right? Number two, it's just simple and it is scalable. You can go to any size of the network, large network. Those are the advantages of layering of communication. Okay. Now there are two popular models, as I said. First one is ISO OSI. ISO stands for International Standards Organization. It is an international organization, as the name implies, which looks after standards. Okay, and it's a multinational body, as said, and every country will have a member representative in that organization. So these member representatives will take care of interests of their countries or concerns of their countries while proposing a standard, making standard, or implementing a standard, any of them. Okay. Now they have come up one model for communication purpose, particularly useful for computer networks or data communication networks, which is known as OSI. Okay, Open System Interconnection Model. It was introduced in 1970s. Okay, though organization was established in 1947, but has been working on different standards. But this OSI model for data communication was introduced in 1970s. Okay. Now let us see how many layers are there, what layers these ISO OSI model proposes. Now, the ISO is an organization, and whereas OSI is the model of communication. Now, ISO OSI model is proposing 7 layers in the entire communication. From, say, a user is existing here, that is a sender. Similarly, the receiving end, there will be receiver here. Okay, so sender end, it passes through all these layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. Then it is handed over to the medium or channel or link, edge, whatever we call it. So that carries at the receiving end, it delivers to the physical layer. From there to data link layer, from there to network layer, from there to transport layer, from there to session layer, from there to physical layer, from there to application layer. Then finally reaches the receiver. So that's how it works. How many layers are there? 7 layers are proposed by ISO OSI, and names of these layers are given here. From, if you read them bottom up: physical, data link, network, transport, session, presentation, and application. Now you can see here actual in the network how they look. Say at A, assume that A and B are N devices, that is A is either sender or receiver, or B is similarly as a receiver or sender. And these are not connected directly, but they are, if they are connected, located nearby, of course they can be connected directly. But in general case, these people normally we have to assume that they are located at different, separated by long distances, where they cannot be connected by directly any single link. So that's why they pass through multiple intermediate nodes. They can be, these intermediate nodes can be routers or switches, whatever, maybe they can be different forms of these things, right? So assume that they are interconnected like this. So whereas at this, one of the end, because it is here data is being originated for transmission, so it user hands out to the application layer in turn hands out to the presentation layer. But in this, of course, everywhere it is processed by to some extent that we will see in the next slide. It hands over to presentation layer, presentation layer in turn hands over to session hands over to transport hands over to network hands over to data link hands over to the physical. this physical layer hands over to the medium, which is courier here. Then it comes to intermediate node, physical, data link, and network. So at the intermediate node, remaining layers are not really required because they only relay the data from one node to another node till it reaches destination node device. Okay, they keep relaying it. So some cases you will have a 2 layers, some cases 3 layers only, not beyond that. At the intermediate nodes, please remember that. Okay. Now, from this network layer, now again coming to this network layer, and from again it comes back to data link layer, network link physical layer to again. So that means at every intermediate node you have 2 parts here. One input, other way output. Input is coming from this physical layer of A and entering into the physical layer of intermediate node 1. Then from there it goes to data link layer here, then network layer, comes to network layer at output side, the same device. Then it comes data link layer of output side, then it's physical link of output side, then it enters this medium again. Then comes here incoming side, input side of intermediate node 2 physical layer. From there it goes to data link layer, there network layer to network layer of output side of data link layer. Then it comes to output side of physical layer. Then it enters to medium. Then this medium comes to physical layer of end B device, that is our receiver device. Then physical to data link to network transport, transportation, presentation to application. Finally, it reaches the user. So that's how communication takes place. Here, if you see here, whatever is process done at the application layer is only can be deprocessed. That means whatever process is done, that can be reverse process can be done by the application layer. So that means whatever is done here only known to the application layer at the receiving layer. No other layer can do. Can understand what application layer has done inside it for the data. Similarly, what is done at the presentation layer can be understood only by presentation layer at the receiving layer, nothing else. Similarly, session layer, whatever is done here can be understood by only session layer. Okay. So because whatever you do here, you have to undo it here, this receiving layer. Then only we get original message back, right? So that's why this is called sometimes peer-to-peer communication or protocol. Peer-to-peer communication or peer-to-peer protocol. So because only layer at sending end, whatever action taken can be undo by the same concerned layer at the receiving layer. No other layer can understand that or do anything like that. Okay, that's why it's called peer-to-peer communication. Now, let's go into further details in that what happens at every layer. So now let's say user at A and B here, and assume that intermediate nodes for some time, ignore them. So to understand this better way, say sender side application, your application is handed over to application layer, but while handing over the message, if it is large, it will be broken into small parts and then handle each part. Sometimes we call it a package, sometimes we call it package, we call it a frame. Different names are there in different places. But let's say for time being, you take it as part of the message, not a full message. So that means message part 1, message part 2, message part like that, and then we n number of parts. So when you combine all of them, it becomes total message. Say first part has come. For that, it adds some header. This header tells source and the destination, from where it is coming and where it has to go, so that intermediate devices can send properly in a proper date, so that you can reach your destination. It attaches that one and so similarly, if any error correction required, flow correction, that all those things will be added here and handed over to the entire thing here. See, at application layer, actual message part is only D7 here, whereas H7 is header part of it. But when it comes to presentation layer here, this H7 plus D7 both together becomes message part to presentation layer. Okay, then it adds its own header part H6. Okay. Then H6 plus D6 both together becomes message part for session layer D5. Then it has its own header H5. Then forward to the transport layer. Transport layer is H5 plus D5. Entire thing becomes message. That means for session layer, right from D7, H7, H6, then H5 all becomes message part. Whereas then it has its own header H4. Then forward to the network layer. Network layer takes this H4 plus D4 as a message part and adds its own header H3. Then forward to the data link layer takes H3 and D3 as a message part and then adds its own header. This T2 is actually trailer we call it, which is for error correction. But this type of thing it exists at every layer. But only thing is here it's not shown because it is included as a part of header itself here. It is not separately shown here, but every place you will have both header and trailer. That's how you have to take it that way. Though here it is shown as exclusive explicitly, but other places is not shown explicitly, but it does exist everywhere. Then physical layer. It takes entire thing as a message part, then adds its own header part, then hand over to the courier, that is medium. Medium simply carries it here, then hand over to the physical layer here. Physical layer removes whatever is inserted, the header part in here. Remaining part is forwarded to the data link layer. Data link layer removes this part, remaining part is forwarded to the network layer. Network layer removes this H3, forwards only D3 part to transport layer. Transport layer removes H4, forwards D4 to session layer. Session layer removes H5, then forwards D5 to presentation layer. Presentation removes H6 and forwards D6 to application. Application removes H7, forwards to D7, which is actual message part of it to receiver. So once it receives like that, all the message parts, receiver can assemble and get the original total message. So that's how it happens. So at sending side, we are going on adding this header trailer at every place. At receiving end, is going on removing at every end. Finally, you extract original message part. So this is how, in a real situation, communication takes place. Okay. Now let us look at these functions of these 7 layers. Okay. Now there is a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application. These are the layers involved, right? So let us see one by one how it works and what are the jobs it is handling that. Okay. And in case time up and the link, session closes, please rejoin for another 5-10 minutes, then we can conclude that. Okay, please don't go back and rejoin them. Okay, now taking the physical layer. So where is it coming? It is coming between medium and data link layer, right? So at sending end, take the input from data link layer and then hand over to the medium, but in between it does something here. So what it does because all the communication here is in computers is a binary communication, right? Everywhere data is represented in a binary form only. Okay, so that binary which has come to the data physical layer is converted into signals. So because on the medium, actual only signals are carried. Okay, so we have to convert into signal form, that is analog form. So that conversion is done at physical layer before handing over to the medium here. Then again, for conversion means it may look at modulation technique, different types of modulation techniques or channel coding, and then converting into handing over to converting signals and handing over to maybe these signals are converted to electrical some cases, or if it is a fiber optic, converted to this one optical signal, and that. And at the same time, this medium, because it is a physical medium connected to this, so there will be a connector part also here, interface. So the connector may be having mechanical as well as electrical characteristics. So when we say mechanical, how many pins, what size, what shape, okay, all those things. Similarly, in electrical, how the signals are represented, how many volts, okay, what is the current level, those things, all those things will be taken care here. Or similarly, if it is optical signal level characteristic. So all those, so that means physical layer converts bits to signals. Then it also takes care of uh, mechanical, electrical, and optical conversions wherever is required on interfaces characteristics of this. Whereas medium simply it carries here and similarly anthos here delivered. Then here the physical layer will reconvert into received signals to the bits, then hand over to the data layer. This jobs done by physical layer sending end as well as receiving end. So physical layer is responsible for movement of individual bits from one hop to the next hop. Okay, and of course it also takes care of electrical, mechanical interfaces and signal conversion. Now coming to next layer, that is network layer. Network layer is coming between physical layer and network layer. Sorry, data link layer. Data link layer. This is coming between physical layer and the network layer. Okay, so here the data is a set of bits. Okay, set of bits between header and tail. So whatever data is received from network layer, it converts into frames. Okay, so the frame we have the data received from network layer plus header and trailer part. This is known as a frame. So it converts into frames and then hand over to the frame. We have some part of some structure, and that we will see as we go into remaining into the subject. So will be this is the specified format. It converts into that and hand over to the physical layer. Okay. Then that means it is dealing with the frames. Whereas if physical layer, if you go back and see, it is dealing with bits, bits and signals. Okay. Here it is dealing with the frames. Please remember. Then at the receiving end takes bits from physical layer, uh, then converts into frame. That frame from the frame, of course, whatever is received from physical and it is in the form of a frame. From that frame, H2 and D2 are removed, and actual data is forwarded to the network layer. So it here also it deals with frame. So always data is dealt in the format of frame. Okay. Now that's a function of data link layer. Now data link layer is responsible for moving frames from one hop to next hop and in the form of frames. Now here we are talking about physical and network layer one hop to next hop. If you see that names one hop to and both the places we get that word hop on hop, right? So that is very important point here, because when you are dealing with data link layer, physical layer, it always deals with only the next hop. That means next device. It need not be end device. It can be intermediate device also. The communication always this becomes a source, this becomes destination. Similarly, between these two, this becomes source, this becomes destination. Here, this becomes source, this becomes destination. For this is applicable for physical and data link layer, both of them. Whereas for remaining layers, this always end system is a source, this end system is always receiver or destination. This is source and this is destination. But whereas at physical and data link layer, always we deal first this one as a source and this as a destination. Then this becomes source, this becomes destination, this becomes source, this becomes destination. That's why one hop at a time we communicate and send it at these two places. Okay, that's the difference. That's the difference between. That's why this is called hop to hop delivery. Please you get that. Okay, and please over. Please, I will come back. I mean, restart again. Please don't go and start. Are you able to see? Hello?
Yes, sir.
Okay, good. Okay. Right, this is called as a hub to hub. Okay, next coming to the network layer functions. Uh, Network layer, what it does, it is coming between transport layer and data link layer. Right? It takes input from transport layer and sender side and generates a packet. That means by adding this header, it becomes a packet. That packet is handed over to the data link layer. Data link layer converts this packet into frames. So that's what. So we are dealing with the packet at network layer. Okay. So at the receiving end, so this packet is received from the data link layer, then removes this H3 header part and hand over to the transport layer. So this is what happens. Now, difference between uh, network layer and remaining physical and data link layer. That we'll see now. The network layer is responsible for delivery of individual packets from the source host to the destination host. Please remember that this is at network layer. The source is always originating station, destination is always end receiving station, final receiving station, not intermediate station. Please remember that. Whereas physical data link layer, always this source and destination keeps changing it at every hop, right? Though the actual data is going from A to B, A to F here in this case, let's say take these two, A and F, but at network layer and above layers, this source is always A, F is always destination. But while it's traveling, at physical layer and data link layer, the source and destination keeps changing it. From here, beginning, this becomes source, this becomes destination. Then again, this becomes source, this becomes destination. Then again, it becomes source, this becomes destination. That's how it keeps hopping it. Okay, but at network layer and above, these source and destination will not change. They remain same everywhere. So that's why you can see here from network layer it's come to physical, data link layer. Here address changes. Only physical layer address changes. Then comes to medium to here. Then this destination of course removed and this destination is removed. Network layer, its original address remains there, and similarly output side of network layer here. Then comes data link layer. Here it adds its address as a source and the next hop as destination. Then forward to the physical layer, it does the same thing and hand over to this. Same thing repeats. So that's how it happens. Okay. So then that's why we call it from network layer and above. This is source to destination delivery. So network layer takes care of source to destination information from source to final destination. This is the function of network layer. Okay. Right. Now coming to the next layer, session layer. This is coming between, transport layer. This is coming between network layer and session layer. Right? So session layer, whatever data is forwarded to transport layer adds its own headers, and then it can come from different applications also that we'll see. So all of them can be multiplexed or demultiplexed. Multiplexed here, sent. Similarly, receiving in, you can demultiplex and send it back to session layer. So this is what done by transport layer. So with transport layer, what is the real function of it? Let's see. Transport layer is responsible for delivery of a message from one process to another process. So please remember this term, process. Okay. Now at any computer, because it's a multi-task system nowadays, multi-process system, right? There is a number of applications running, number of processes running at both sender side and receiver side. So each process will have a different number. So each process can communicate with a different process at the receiving end. Maybe one process of this can communicate with one process of this system. Maybe another process can be communicating to another process of the same system, or can be in a different system also at a different address. Okay, that's why network layer takes care of only between source system and destination system. But whereas transport layer takes care of connection between process of sending side to process of destination. So this is different. That's why it's called a process to process delivery. Whereas network layer, host to host delivery, node to node delivery. Whereas here process to process delivery. So that's the difference between transport layer and network layer. Now coming to session layer. Session layer comes between presentation layer and transport layer. Are you there? Okay, okay. Now because I'm not able to see you this way. Okay, fine. You are there, so that's okay. Yeah. It's coming between presentation layer and transport layer. So whatever the issue for presentation layer and for the it does some action here and then hand over to the transport layer. Similarly, receiving a transport layer takes and then redo the work done by session layer of center, then hand over to the presentation. So the work done by here is synchronization, mainly synchronization and timing. Okay, so assume that you have to run some process and it is in a dialogue fashion. That means you are sending a query and getting a response back. That means suppose you are logging, you are asking a password or is the name. When it comes, then you have to go further. So that means you have to synchronize. When the data comes, then only you have to take the next step. So when the password or username comes, then only you have to take it. That means you have to synchronize with that. Okay. Suppose you are running a big program by one application where it needs input. At certain stage, it needs input from another process. So another process to complete and generate the output. That output should come as input to the current process. Then only it can proceed further. So if there is a delay of the second process, which is in generating the output, which is input to this current process, you have to wait. Right? This process has to wait till that is completed. So that is known as synchronization. So this synchronization and timing is and dialogue, session dialogue, is taken care by session layer. So that is a function of it. So session layer is responsible for dialogue, control, and synchronization. That's it. Okay. Now coming to the presentation layer. It is coming between application layer and session layer and takes the application data coming from application layer and adds its own agenda in that. Similarly, the same again takes from session layer and undo that and then send to the. But the work done by here is mainly conversion, data conversion. So data conversion is required at in several incidents cases. Number one, whose sending side and receiving side are not following the same format of the data. When you say that format, the data is can be arranged in a format of ASCII or it can be everything. Different formats are there. So unless these two are following the same format, they will not be able to understand the data. So either they have to follow the same thing or they have to come to a neutral one in between. So that conversion is done by the presentation layer. Another case, suppose you need a security that is encrypted, you need the encryption. So that encryption is done at the sending side presentation layer and it is decrypted at the presentation layer of receiving side. Similarly, some cases you need a compression. That compression is done at the layer of presentation layer of sending side. Decompression is done and the presentation of receiving side. So these are the